Okay, Assalamualaikum warahmatullahi wabarakatuh. So inshallah we will learn our last chapter, which is AC circuit. So for AC circuit consists of LRC series circuit, alternating current circuit, phasor diagram and power. Here you can see the difference between the direct current and the alternating current. For direct current, the short form is the DC, the acronym is DC, it stands for direct current. And for alternating current, AC, A for alternating, C for current. And the difference you can see is about the direction of the current of or electron. For example, if we talk about electron, so the direction is from negative to positive. If we talk about direction of current, the direction is from positive to negative. For direct current, the direction is only one way. But for the alternating current, you can see that the the movement of the electron or the current is in the back and forth, two ways. Okay, and the symbol for alternating current, you can see that this is the symbol for alternating voltage. Okay, so for the AC circuit, you will produce a sinusoidal voltage of frequency F. Okay, sinusoidal voltage. And okay, so sinusoidal voltage, and the EMF give rise to the current. So this is the form the I. Okay, the I for the I the current, the formula for current for AC, where I equals to I naught cos omega t. Okay, and this I naught is the peak. Okay, the maximum current or the peak current. Okay, so they will reverse positive and negative current over time. And source of voltage, for example, we have here generator. Okay, and then for I peak, this is the I peak, and this is the V peak. Okay, so for I peak, if you want to find the I maximum or maximum current, the formula will be I RMS times with Z2. This one times, okay, I RMS times with Z2. RMS stands for root mean square. Root mean square. Okay, so for the V peak equals to V RMS times with Z2. Okay, where RMS is root mean square. Right. So when the resistor be connected to the AC, this is the AC voltage. Okay, the characteristics of the graph will be current and voltage will be in phase. Okay, current I and voltage V will be in phase. So for this circuit, okay, I and V in phase. What is in phase? Okay, so if in phase means that the I and V will be at the maximum, minimum, and zero at the same time. For example, here for this time here, okay, you can see that for t here, let's say t here is 5, for example. For example, 5. You can see that at 5 seconds, V and t is 0. Okay, let's say we put here the value, let's say 8. Okay, at 8 seconds, V and t at the maximum. And here, for example, we put as a 3. Okay, so let's say for here 3. So at 3, you can see both at the minimum points or the lowest point. Okay, so in phase means that they are together. When when at the same time they will be 0. At the same time they will be both of them will be maximum. At the same time both of them will be in minimum state. Right. So that's the characteristic for the resistors that be connected to AC voltage. Okay, so just now we have know that for I equals to I naught cos omega t. For V equals to V naught cos omega t. Okay, so this one for if you want to find the I. Okay, instantaneous I. Let's say we want to find I at 5 seconds, so we use this equation. I at 4 seconds. Okay, it will depends on the t. V also we need to use like this. V equals to V naught cos omega t, right? So this is the very important statement. V and I are in phase, okay? Because when I 0, V will be also 0. Okay? When I reaches the peak, V also reaches the peak. Okay? So then for P, for the power, average power, you can see here, P average will be I squared RMS times with R, or V squared RMS times with R. Okay, we know that P is I squared R, or P equals to IV. Okay, but if you want to find the average here, P average, so uh, P average, so this one will be I RMS squared R equals to I. Okay, just let we will use this equation first. Okay, I don't want you to be confused. Okay, so for this one, for the P average, I RMS squared times with R. Okay, and if you want, let's say to use the IV, so it will be I RMS V RMS. Okay, right. So this this is for inductor. This one inductance. Inductor. Okay, you can say that the inductor. Okay, like this. Inductor. The previous chapter. L being connected to the AC. Okay. So the characteristics of the graph. Okay, you can see here. The current I lags voltage by a quarter cycle or 90 degree. Okay, so I lags V by 90 degree, or you can see that V leads I by 90 degree. Okay, V leads I by 90 degree. So from the graph, you can see that V is in front of the I in 90 degree. For example, here. Okay, uh, for let's say we have a peak, let's say here at this point, you can see that V is reaches the peak. V naught here. Okay, where is the I naught? This is the I naught. Okay, and we can see that V is reaches the peak faster than I. And if we use the phasor diagram, we will find out that the degree is 90 degree. The phase the 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 phase is 90. The phase difference is 90 degree. But here you can see that V leads I. It means that V is in front of I. Okay, we can see that because why? Let's say T here. Let's say we put here. Let's say this one 6. This one 8 second. So at 6 second, V already reaches the peak. Then at 8 second later, after that, I reaches the peak. So means that V leads I. Okay, V is in front of the I by 90 degree. And right, so when we say about leads here, so in terms of equation, we will put plus. Okay, plus 90 degree. And then okay, here, so here we can see that V plus 90 degree. Okay, because V leads I. Okay, this one is the voltage. If you want to get the voltage for the inductance, we know that for normal one V equals to IR. For the resistor is V equals to IR, but for inductance V equals to L di over dt. Di is the different the changes in I over the changes in T. Okay. Okay, this is the peak voltage. So peak voltage V naught equals to I naught SL. Okay, what is SL? Okay, SL is the uh, SL is the resistance reactance for the for the inductor. Okay, as we know that the resistor equals for resistor we have V equals to IR. Okay, while R is the resistance, but for the inductance V equals to I X L. Okay, while V is the voltage, I is the current, and SL is the reactance for the inductor. Okay, uh, if you want to find the peak voltage, I will be I peak. Okay, alright. So SL, okay, SL what is SL? Okay, SL is omega L. Okay, SL is omega L. While omega is, you can see here, omega is 2 pi f. 2 pi f. Okay, omega is the angular frequency, L is the inductance in Henry, and if you want to substitute the value for frequency here, it means that omega will become 2 pi f. F is the frequency of the circuit, so 2 pi f in hertz. F is in hertz, Hz hertz. Okay, times with the inductance L. And this one, um, the characteristic of the graph, if you connect the capacitor, okay, capacitor with the AC voltage. Okay, so when we connect the capacitor to the AC source or AC voltage, you can see that the current leads voltage by 90 degree. Okay, so we can write here I leads V by 90 degree, or in other words, V lags I by 90 degree. So lags here, V lags I. Lags here, we will put negative. Okay, here. So negative here will mean because of the lags, okay, lagging. So V lags I. So V is behind the I by 90 degree. For example, here we can see at this graph. For example, I, let's see here at the peak. So this is the I peak. This is the V peak. Okay. So we can see the I reaches the peak first. Then after that, V reach the peak. Right. So means that I is in front, leads the V, while V lags the I. Okay. Okay. So because of the lags, okay, V lags I, so we put negative here to represent the lagging. Alright. And again, if you want to find the peak, okay, I have told you before that for the resistor V equals to IR. Okay. For the inductance V equals to I XL. Okay, and for the capacitor V equals to I XC. Okay, so if you want to find the peak, so V will be V peak and I will be I peak. Okay, and XC here is the reactance for the capacitor, where for XC, okay, for XC equals to 1 over omega C. Okay, here we can see here inductive reactance. So Xc is omega times with the C at 1 over omega C. So omega is 2 pi f, and C is the value of capacitance. Okay, right. So for the RC circuits means that we combine resistor inductance and capacitor, resistor, inductor and capacitor in a series circuit. So the characteristic of this graph, okay, but before that we have learned about individual characteristics. Okay, so we know that for for inductor, okay, V naught equals to I naught SL. But if you want to find the V average, it will be V RMS equals to I RMS SL. For voltage across the capacitor, V RMS equals to I RMS SC. If you want to find the peak, it will be V naught equals to I naught times V at C. For the resistor, VIR, V equals to IR, so V RMS equals to I RMS times V R, or V naught equals to I naught times V R. So there are two things here. First, if the question asks you to find the average, okay, or the question asks you to find the peak. If average, so for example, for inductor, so you will use V naught equals V RMS equals to I RMS times with SL. Okay, for the okay I will write it again. Okay, and we have two things here. First is about average. Okay, if you want to find the average, so let's say for the resistor. Okay, for the resistor, so for the resistor the average is V equals to IR, but here V here we will use V RMS, I RMS. Okay, if you use the capacitor C, so V equals to I x C, but V here will be V RMS and I RMS. Okay, and we use the and if you use the inductor, so for inductor V equals to I SL, and if V RMS, I will be I RMS. Okay, times with SL. Okay, again, if you want to, another thing is if you want to find the peak, the maximum. Okay, for the peak, okay, let's say for the R, so for the R we know that V equals to IR, but the value for V we need use the V maximum or V peak, and I is I maximum, I peak. For C we will use V peak equals to I peak times with XC. For L inductor we will use V peak I peak XL. So you will calculate here, you will obtain the desired value. Let's say you want to calculate the V or R. Okay, but bear in mind that if you want to find the average, you need to use the RMS value. If you want to find the peak, you need to use V peak and I peak. The knot here represent the peak, the maximum value. Okay, right. Then for total current in circuit, so if we combine all the resistance and reactance, we will find out that V equals to IZ. V equals to IZ. If you use the V peak, I will be I peak. Okay. If you use the you want to find the average, so V RMS equals to I RMS times with Z. Okay. So RMS here is the average, and V naught here is the peak. Okay. What about Z? So Z is the impedance. Okay, Z is the impedance. For the Z is the impedance. Okay. So you can see that Z is R squared plus SL minus SC squared, square root. Okay. And SL here is omega L minus 1 over omega C squared, and square root here. Okay. Because Z, okay, for this one, why is like this? Because we use theorem Pythagoras. Because this is R SL, this is SL, and going down is at C. Okay, let's say SL is bigger than C, so your graph will be the Z will be here. So when you draw this one will be SL minus SC. Okay, minus SC. So to find the Z here, the hypotenuse here, so you use the Pythagoras theorem. So it will be R squared plus SL minus SC square root. Okay, this. If let's say SC is bigger than SL, okay, it will be opposite. Okay, so then the power factor, the cos psi, is the R over Z. Okay, R over Z, resistance over impedance, and the phase angle here is the tangent theta. Okay, or you can find if then after tangent theta here, you need to find the theta. Okay, make sure you find the theta, not the tangent theta or tangent psi. Okay, let's say here we have the graph. So you have here the psi. So you want to find the sine. You can use the tangent, or actually you can use other uh, trigonometry such as sine, cos, and so on. But if you want to use tangent, so here will be XL minus XC. Okay, XL minus XC, and C here, this is the C, and this is the R. Okay, so psi is the tangent negative 1, so psi will be tangent negative 1. Okay, XL minus XC over R. Okay, this is the phase angle, right? And then the RMS current in an AC circuit, so we know that V equals to IZ, so I equals to V over Z. Okay, so if you want to find the RMS, so this one will be RMS, and Z is the hypotenuse, so we need to use like this, R squared plus omega L minus this one. Actually this one is R squared. Actually we know that Z equals to Z R squared plus SL minus XC squared. Okay, right. So IRMS depends on frequency. That when we can see that if IRMS maximum happen when XC equals to SL, and this occurs, we call it as a resonance. Okay, when these two equal, SL and XC is equal, we get 0 here. So we will get omega naught like this, 1 over LC. Okay, and at this point we can call that this is the resonance value. Okay, resonance value. Okay, for the resonance frequency, you can see the shape of the graph will be like this. Okay, the resonance speed will be like this if you use the small r. Okay, and we use the large R. And lastly, about phasor diagram. Okay, is the projection of rotating vector onto the horizontal axis represent the instantaneous current. So it is the projection, okay, of rotating vector, right? So for resistor, we have learned before that resistor is in phase, in phase, I and V in phase. So you can see that V and I, or I and V, in same phase. Okay, so this is for resistor, and phasor diagram is moving anti-clockwise like this. Okay, and for capacitor, we will draw like this. Okay, and the degree here is 90 degree, and for inductor, V leads I will be like this, 90 degree. Okay, and this is the thing that we have learned before. For the IV and so on, IV in phase, this one in phase. Capacitor, for capacitor, I leads V or V leads I. Okay, V leads I. Okay, or I leads V. This one V leads I. Sorry, this one is V lags I. Okay, I leads V for this one. V lags I. Means that I is in front of V. I is in front of V by 90 degree. For inductor, V leads I. So this one V leads I by 90 degree. For resistor, we know that V and I in phase. Okay. This is the combination of all the in the LRC circuit. Okay, in the LRC circuit. Okay, if you draw the LRC circuit, so we have here as a VR. Okay, so this will be the VR there. So we have VL. So we have VC. Okay, so we will get something like this. Okay, when the rotating is anti-clockwise. Okay. Okay, this is the thing that I told in the previous slide. So the location of VL, VC, and VR. Okay, so this one put 90 degree and this one is 90 degree, and the rotation is anti-clockwise. Okay. Okay, this is the example. Okay, you can see that these three parameters L, R, and V, and C always 90 degree with each other, and the rotation is like this. Okay, counterclockwise. Okay, always counterclockwise and 90 degree. Okay, same with the previous slide. Okay, okay, this is the summary. Okay, so this is what you have learned before about the when this one. I mean I and V in phase. Okay, this one for the resistor. This one is for phasor diagram for the in phase. This one current leads voltage. Okay, current leads voltage leads, and this one current lags voltage. Okay, current lags voltage. Okay, and lastly about the power. Okay, the normal one we know that P equals to IV, but for the AC we will use as a P equals to IV cos psi or cos theta. This one V is will be RMS and V are RMS, like this equation. Okay, like this equation. Or we can also use half, because average we can use the half times the IV cos psi. Right? So this is one of the example here. Okay. So okay, I just want to summarize the question. So this is the R, L, and C. Okay, make sure this one you convert to Henry. So it will be L equals to 30 times 10 to the power of negative 3 Henry. And this one C will be 12 times 10 to the power of negative 6 farad. Okay, this is the VRMS. Okay, this is the frequency, the F. Calculate the current. The question asks you to find the I. Calculate the VRMS across each element. Calculate the phase angle. Lastly, the power dissipated. Okay, right. So you can try this question. Okay, it's very easy, very straightforward. The question. Let's say for the power dissipated, phase angle, and so on, we have that in the previous slides. Okay, you can try first. Okay, and this is the solution. Okay, right. Thank you for listening, and hopeful that you will learn, study hard, and inshallah you will success. Okay, Assalamualaikum.